Alright, part 2 calculus. Let's start with, says find dy dx of ln of square root of x squared plus 10. So let's use, first let's rewrite this. Okay, so we're going to rewrite it as ln of x to the half is 1/2 of that. So this right here becomes to the half power. Put the half in front using the college algebra rules. So now we have this. Now we take the derivative. Derivative means derivative on top, f prime of x over g over f of x. So derivative of the top is 2x plus 0. The bond stays the same. So this is going to be 2x. And then 2 and 2 are matching. 2 matches 2. This is gone. So we end up with x over x squared plus 10, or dy dx is x squared plus 10. Alright. Evaluate the derivative of the sine inverse of that. Well, there's a formula. Sine inverse is going to be derivative is this. So now, sine inverse is this. So it's going to be this right here, prime on top over square root of 1 minus 7x to the fifth to the second power. Well, the derivative of this is going to be 35x4. And this twice, 7x5, 7x5. So 35x to the fourth over 1 minus 49x to the 10. 7, 7, 5, 5, add them together. Tangent inverse. So 3 tangent inverse of this, there's a formula. So we're going to take the derivative on top, and this plus the function squared, and put 3 here. 3 times that is 9, so 9 over 1 plus 3x to the power of 2. And then let's leave it alone. That's fine. Cotangent inverse of e to the s power. Well, here's a derivative cotangent, here's the one for the e function. So f of s is that. F prime means put the function on top, derivative of course, and the minus, and then in the bottom we have this plus the function squared. So derivative of e to the s is e to the s times s prime. S prime is a 1. 1 times that is same thing on top. Bottom part, e to the s to the second means 2 times s is 2s. So negative e to the s over 1 plus e to the 2s is the final answer. The size of a square increases the length of 6 meters per second. There it is, and they're getting bigger. So at what rate is the area of the square changing when the size is 15, when it's 23? So let's put, so ds dt is that. S is 15, S is 23. So now start with this. Area of the square is that. Take derivative. dA dt equals 2s ds dt. So now let's put numbers in here. So there's this, the derivatives right there. So now we know that this is 15. We know this is 6. So dA dt, there he is changing it how? That turns out that is 180 meters per squared per second. Second part, what happens with this 23? Well, just put 2, 23, and 6. We're going to get 276. So we have 276 meters squared per second. Find the equation of a tangent line. Okay, let's do that. So now, first find the derivative. Y equals that. Y prime is 2x minus 0, 2x. Put the number 4 in there. Y prime of 4 is going to give you 8, which is n, which is the slope. We have point slope formula. And we have x1, y1. Let's put the numbers in. Y minus 12, 8, x minus 4. So we have this minus 12, this times this times this. 8x minus 32, at 12, at 12. These are gone, so we have y equals 8x minus 20. At the time t, the position of the body moving along the s-axis is this. Find the displacement of the body from t equals 0 to 3. So s of 3 minus s of 0, put it in the machine or do it a long way. That's going to be 27. That's going to be 81, 72, 0, 0, 0, 0. This is going to be 18 minus 0. 18 minus 0 is 18. This one, use implicit differentiation to find this. That's fine. So let's go from here. Let's put the problem here. The derivative of this, and this. The derivative of this is a product. So it's going to be first times last, first times last. Prime the first, prime the last. That's going to be a 1. And the 0, 2 is 0. So now we have 1 times y plus x times y prime plus 1. Bring it down. So y plus xy prime plus 1 is that. So now we have this. Now subtract 1, subtract 1. So xy plus xy prime equals negative 1. Subtract y, subtract y. So we have negative x, negative 1, negative y on this side. Now divide by x, and these will cancel. So now we have y prime is this, or take the minus out, right there. So we have factored out y prime equals this, or dy dx equals negative of that. Find the derivative of log base 4 of this guy. So use the log rule first. We're going to rewrite it to the half power. And then we're going to put the power in front. Now we take the derivative of this. The derivative of log base 4, right here, log base b, whatever you want it to be, is ln of b, f prime over f. So the derivative of this, original function, ln 4. So the derivative of this is 9 minus that. That's going to be 9 plus 0 is 9. And you have ln 4 of that. Now, that's all we can do. Yep. So let's put the 9 on top, the 2 on the bottom, ln 4 right there, and 9x plus 3 there. Boyle law states that the temperature of a gas remains constant, then PV equals C, where P is pressure, V is volume, and C is a constant. Given a quantity of gas at a constant temperature, if V decreasing, means it's a negative, at a rate of 9, that right there, decreasing, negative, what rate is P increasing when P equals 80 and V is 50? There they are. So let's see. Let's find the derivative first. F times G. So this is going to be a product. That's constant, that's going to be 0. So prime the first, prime the last. So this is going to be P prime V plus PV prime. dP dt of V plus P dV dt over here. So now, dP dt we don't know. 50 we do know, volume. And 80 we know from there. And negative 9 we know from that. Put them in there. So now we have, rewrite this. So now we have negative 720 at 720 to both sides. So we have P 50 dP of that equals that. Divide by 50, divide by 50. And dP over dt equals 720 over 50. And all I can do with it is take a 10 out. 10 times that, 10 times that. These cancel. So you got 72 over 5. That's it. Pounds per inch squared. Pounds, yeah, for inch squared per second. Determine the graph, where the graph has absolute max, absolute means, I guess. Alright. So the graph absolute max is right there. It is included in that point. So at this D, it's a max. Minimum, well, it's open circle. So that means that there is no absolute minimum right there. Absolute max, yes. Absolute min, no. Critical points. Find the critical points of this means take the derivative, set it equal to 0. So here's the problem. Take the derivative, 10x plus 3 minus that. Set it equal to 0. 10x plus 3 equals that. Minus 3 minus 3. 10x is that. Divide by 10, divide by 10. So x equals negative 3 over 10. There's a critical point right there. Derivative, set it equal to 0. So now we have another critical point. So take the original problem, rewrite it a little bit. Take the derivative now. It's going to be 3x squared, this number, plus 9x is 9. So now we have this equal to 0. So rewrite it this way. 9 minus x squared. A squared minus b squared, a plus b. So 3 squared minus x squared is 3 plus x, 3 minus x. 3 plus x equals 0, 3 minus x equals 0. Minus 3 minus 3, so x is negative 3. 3 minus x minus 3 minus 3, so negative x equals negative 3. Multiplied by negative 1, 3. So negative 3 and positive 3 are the critical points for this guy. Determine the location, the value, absolute, extreme value, max, means, whatever. Okay. There's a problem. Take the derivative. It's going to be negative 2x plus 0, negative 2x. Divide by negative 2, divide by negative 2, x equals 0. But we have endpoints. We have 3, and negative 3 and 4, so we're going to take those in consideration. So those are all the points we need to think about. So f of 0 original gives us that. F of negative 3 gives us that. F of positive 4 gives us that. So the max is that one. And the min, the lowest number, was that one. So absolute max at 0, 12. Absolute min at 4, negative 4. Alright. Stone is launched vertically upward from a cliff 384 feet above the ground at a speed of 32 feet per second. The height above the ground t seconds after the launch is given by this, between 0 and 6. When does the stone reach its maximum height? Okay, that's fine. Take the derivative. This is the original problem. Derivative is negative 2t plus that and that. So that's prime of t is negative 32t plus 32. Now set that equal to 0. Minus 32 minus 32. So divide by negative 32, divide by negative 3, so t equals 1. That's a critical point. So now, to the left of it, 0. To the right of it, 2. Just take those numbers. S prime of 0, we ended up with a positive, which is increasing. And S prime of 2 over here, we ended up this decreasing. So it's going up, down. So right here is going to be what? The max. The max is going to be at t equals what? 1. At what point C does the conclusion of the mean value theorem hold for f of x is x cubed and an interval from negative 14 to 14? Alright. So, first take the derivative. It's going to be 3x squared. And here's the mean value theorem right here. F of b minus f of a over b minus a equals f prime of c on this interval. F of 14 minus f of minus 14. 14 minus minus 14. So 14 cubed is this. Negative 14 cubed is that. So negative negative is positive. Add them together is this number. 28 equals 3x squared. 3x squared all the way across. Divide them. 196. Divide by 3. Divide by 3. Well, it doesn't go in there. So let's take square root of this. Square root of this. So square root of 91 top. Square root of the bottom is x. Square root of that is going to be plus or minus 14 over square root of 3. And multiply by square root of 3. Square root of 3. That times that is square root of 3 squared. That one leave it alone. So square root of 3 squared is 3. So plus or minus 14 square root of 3, or x is 14 square root of 3 over 3, and x equals negative 14 square root of 3 over 3. Determine whether mean value theorem applies to the function, this one, and interval there. Okay, let's take the derivative first. Take the derivative, it's going to give you 0 minus 2x minus 2x. So f of 2 minus f of negative 1, 2 over negative 1 from those two numbers right there is a derivative. So now 6 minus 2 squared, 6 minus minus 1, that's going to be 6 minus 4, 6 minus 1, and that's going to give you 2 minus 5 is minus 3 over 3. Divide those two numbers, is going to give you negative 1 equals negative 2x. Divide by negative 2, divide by negative 2, so 1/2, positive 1/2 equals x is the answer. Find intervals which is increasing or decreasing. Okay, take the derivative. F prime of x equals 0 minus 2x. Derivative is minus 2x. Set equals 0, we get 0. Try number before and after. F of negative 1, f prime of negative 1 is greater than 0, so it's increasing. F of positive 1 is less than 0, is decreasing, so it's increasing, decreasing. So increasing from negative infinity to 0, and decreasing from 0 to infinity. Right there. Find intervals where this thing is increasing or decreasing. That's fine. Let's go. Take the derivative first. So we have 0 minus 1 plus 6x, negative 1 plus 6x. Set that equal to 0. Negative plus 1, so 6x equals that. Divide by 6, divide by 6, so 1 over 6. So now, what happens before -1 and positive 1. So f prime of -1 is a negative, so it's decreasing. And f prime of 1 is increasing, so decreasing, increasing. So this right here, so before the 1, 6, what is it doing? It's decreasing from negative infinity to 1, 6. And then after that, it's increasing from positive 1, 6 to 8. Locate the critical points, use the second derivative test. That's fine. So there's the original, to perform this. Here's the problem. Take the derivative, first derivative, second derivative. Set the first derivative equal to 0, minus 3x out. This is equal to 0, that equals 0. So eventually we're going to get divided by 3, 0. And we get 10. 0 and 10. Now, second derivative test. Let's put it in there. F double prime of 0 is that times 0 plus 30. So 30 is greater than 0, so it's concave up. That means there's a min right there. Next one, f double prime of 10 is going to give you negative 6 times that is negative 60 plus 30. So that's going to be negative 30. So that means it's concave down. So we have a max and we have a min. So max at x equals 0. Let me see. And max. No. Let me see. What do we have? Let me see. Oh, min. Yes, min. Min, x equals 0. And we have a max at x equals 10. There they are. Right there. Alright. Look at the critical points of the following. Use the second derivative test. Fine. There's a problem. Take the derivative. And now take the second derivative for that. So now set the first derivative equals 0. Factor in. It's going to be negative 6x equals 0. X plus 4 equals 0. So we have, next step, next page. We have divide by negative 6, divide by negative 6, 0. We have a negative 4. F double prime of 0 is a negative 24. Less than 0, concave down, means this is a max. F double prime of negative 4 is going to be negative, negative, positive. It's going to be greater than 0, concave up. So that means we have min and a max. Max at x equals 0, and we have min at x equals negative 4. It says, use linear approximation to estimate the following quantity. So for this one, ln of 1.09. So what we're going to do is we're going to say f of x is this, f prime of x is that. So put it in there, the linear approximation. F of a, f prime of a, x minus a. So we're going to put ln, L of 1.09, f of 1, f prime of that times that. Ln of 1 is 0. The derivative is 1 over 1 is 1 times that. 0 plus that. So 1.09 approximation will be 0.09. So the following function, there's the original function, take the derivative of it. It's going to be 6x squared minus 4. So dy dx is this, multiplied by dx, so dy equals this times dx. The hospital rule, hospital. That means this limit and the derivative limit is the same. So let's do it. So you have this original problem. Take the derivative on top, derivative bottom. Derivative bottom is 5x, it's going to be 5. The derivative of sine is going to be cosine of 7x times 7x prime. So that's going to give you 7 times that is 42 cosine of that. Now put the 0 in there. 42 cosine of 0. 1 times that is 42. 42 over 5. Leave it alone. Calculations on the calculator. Use the calculator program to compute the 10 first 10 iterations of Newton's method when they're applied to the following function. Right, here's a function. There's the x0. So start with x0, 5. Put it in there. So 5 and f of 5 or f prime of 5. F of 5 is this, f prime of 5 is that. So when you work it out. 5 minus 0.20 is going to give you 4.8000. There they are. So now, once you get this answer, put it back in here, do it again. 4.8 minus f of 4.8, f prime of 4.8. Work it out. We're going to end up with this, which is 4.795833. Keep going on, but you're going to find out that it's the same. Use your calculator, of course. use this machine. Alright, determine the following integral. So x to the n plus 1, n plus 1. So this one is going to be 9, 17 plus 1, 11, 21 plus 1. That's going to give you 9x 18 or 18, 22 that. Break it up, 9 times 2, 11 times 2, cancel the numbers. X 18 over 2 minus x 22 over 2 plus c. We're done. Then we'll go this, rewrite it as a half power, bring it to the top. So now 1 half plus 1, 1 half plus 1, negative 1 half plus 1, negative 1 half plus 2, 2, 2, 2. So that's going to give you positive half, positive half. That's going to give you 3 halves, 3 halves. Flip this around, flip this around. So now multiply 3 across is 20. Multiply 3 across is 30 over 20 over 3. And this can convert it back to the square root symbol. That's how we're done. Nothing else to do. Well, let's do it the first way. You can use this formula right here. So you have this down to the power. The derivative of this thing. Let's see, what's it going to be? I see something here. Let's see. So this one says that. And the derivative of this part is actually a 6. So let's put a 6 there. 6 and 1 6. So this is actually going to be okay, and the 1 6 is still there, and the 1 6 is still there. So actually it's going to turn out to be 1 over 18 times 6x plus 5 to the 3 power plus c. This is the right answer right there, because it wasn't 6, but we fixed it. See how we fixed it right there? Now the next one, well, we could also do is multiply out the long way, and then once you get it there, then we do each one. So we ended up with 12x cubed, 30x squared plus 25x plus c, and then we're done. 2 ways to do it, but you gotta have that derivative right there to use this formula right here. Multiply it out. So we have this, integrate it. First one, second one, last part. So 4 divides this, yes. 3 divides that, no. Leave it like that, and we're done. Let's see, this one. So we're right there. Let's add 1, 3, 3, 3, 3. So this is going to give you 4 thirds, 4 thirds, 2 thirds, 2 thirds. Flip this around like this, flip this around. 11x plus c. So now, since 4 is 2, 2, this cancels. And we have 3 over 2. And nothing goes on here, so it's going to be 9 over 2. X and 11x, and then the c. We're done. That's it. This one. Let's find it, rewrite it. This is 4, 6 of that. It's going to be to the 1 6 plus 1 plus 1. It's going to be 6 over 6, 6 over 6, 7 6, 7 6. Flip this around. 6 over 7 times this plus c. So this is going to give you 24 over 7 of that plus c. That's all we can do. We're done. This one, let's just go ahead and FOIL it out first. Multiply it out the long way. Rewrite it. 7x squared, 27x plus 4. Now integrate each one. So this is going to be 2 plus 1, 1 plus 1. It's going to be a 3, and that's going to be a 2, and then 4x. Let's see, that's it, we're done. Nothing else I can do. Easy way, just multiply it out. This one, go ahead, let's divide them out first. Break it up into 2 fractions. And this will be this one, this will be this one. So now we have 4x cubed minus 9x squared. Now integrate each one. 3 plus 1, 3 plus 1, 2 plus 1, 2 plus 1. So that's going to be 4, 4. 4's cancel. And 3 cancels it. Yes, 3 right here. And then plus c. Let's say we're done. For the following function, find the antiderivative, big F. Okay, so there it is. Integrate, that's f of x. So now, 4x to the 3 plus 1, the derivative of negative cosine is sine, and plus c. So 4 divides 4, x to 4 minus 5 cosine x plus that. Now, they give you an initial condition of f of 0 is 2. Put in f of 0, 0, 0 plus equals 2. So that's 0 minus 5 plus that. 0 minus 5 is that. So minus 5 plus that. Add 5. So c is 7. So the final answer is f of x is x4 minus 5 cosine x plus 7. Given the following velocity function of an object moving along the line, find the position function, give the initial position. Okay. Let's integrate this, both sides. Integral of this, it's going to give you this. At 1, minus 5t plus c. So we have this, and this. Divide this number, S is 0, put 0, 0, 0, plus c is 0. 0, 0, 0, 0 plus c, so z must be what, 0? So final answer S of t must be t cubed, and 3t squared minus 5t, that's it, with the initial condition in it. Alright, find the absolute extreme of this guy. Okay, cube root of that, from there, from negative 8. So x cubed from where? From negative 8 to 64. So f prime of x is going to be 1/3 minus 1, minus 3, minus 2/3. And then we're going to rewrite it. This is going to give you x to the 2/3 on the bottom. And notice that it's undefined when x equals 0. But we have other points. We have negative 8, we have 64, and we have 0. So f of negative 8 is cube root of this is negative 2. F of 0 is 0. F of 64 is 4. So now, from all these, the absolute max is 64 is 4, that one. And the absolute min is at negative 8, which is a negative 2.